And on that note, we can get started. I would like to introduce our presenters for today, Gregory Pearson, who is the water and wastewater trainer from the Great Lakes Environmental Infrastructure Center at Michigan's Technological University. And also joining us today is Dr. Jason Barrett, who's the Associate Extension Professor and Associate Director from Mississippi Water Resources Research Institute at Mississippi State University. He will be joining us to answer some questions. So welcome, Greg, and I will go ahead and hand it over to you.
Great, thank you, Owen, and welcome everyone. We'll get the screen up here. We're happy that you're all here today, and we're especially blessed to have Dr. Barrett with us today. And I'll be bringing Dr. Barrett in on some of the questions and some of the topics. I'm going to go off of webcam for now, and we'll come back in when we have some discussions. Now, once again, we're talking about inspection tasks for on-site wastewater systems today. We've had this is part 3 in a 4-part series that we've been kind of alternating between Mississippi State and Michigan Tech. And so in the last couple of webinars, we talked about basics, and last time we talked about processes, the underlying organic processes, and today we're talking about inspection. And I want you to imagine for a second, you're working for a local community or a county or a tribal community or some kind of local jurisdiction, and you're assigned to develop an on-site wastewater inspection program. What kind of questions might you have if you were new to on-site wastewater? Well, you might ask, what kind of standards, what kind of measurements are we looking to adhere to? How often do we need to inspect? What components are we actually going to inspect? What is the overall goal of on-site wastewater inspection? How do I know when the system is functioning properly? And what are some variables that can affect the performance of our on-site system? So to address some of these topics today, we're going to cover a few points. We're going to look at some basic design standards, some of the concepts that we use to investigate the initial site, because that links back to our inspection. Actual tasks that we're going to use to inspect the septic tank, some concepts to inspect leach fields or the drain field area, and we're going to talk about some common problems that can occur that you can keep an eye out for. We're going to start with our first poll, and Owen can bring that up for us. We're going to be asking about your role. And I can't see it, Owen, so you can feel free to talk through it and present the results.
Yeah, sounds good. I launched it. I'll just give it a minute and let you know. Okay, we'll give it another 10 seconds. Okay, so for the poll, we have majority of people are in the other column, and in I conduct regulatory oversight of on-site systems. That was about 50%, and then for the other column, that's about 33%. Some of the responses that we got back: consultant in water and wastewater, consultant for municipalities, one person works for a state-run water and sewer authority. A lot of stuff in that sort of realm.
Great. Well, welcome everyone, and thank you for participating in the polls. That helps us to know a little bit more about our audience, and we can tell there's a lot of people that are interested in protecting groundwater quality on the line here today. So I wanted to share with you the first step in inspecting a septic is you get into the septic like this. No, we definitely want to keep in mind safety. So I want to mention safety briefly up front. You always want to protect yourself from microbiological risk and risk of actually falling into a septic tank. You don't even want to place your head into an inspection port to look inside because there's the possibility of toxic gases that could affect your health. So you never want to get into a septic tank. And it looks like this gentleman was installing some kind of pump system before there was any wastewater. It still doesn't look like a good idea to me, but you always want to protect yourself from contamination. You want to have PPE to protect your hands and use good hygienic practices not to contaminate anything that you might be eating or using or drinking. Now, we've been establishing the basics of wastewater, on-site wastewater systems in Module 1, taught by Dr. Jason Barrett. And in the last session, we talked about on-site treatment processes. And we established that the septic tank, the purpose of the septic tank is to separate the solids from the liquid, and anaerobic decomposition occurs. And in the drain field or leach field, that's where the majority of our effluent treatment actually takes place. And before that water drains through that biomat and the soil and reaches groundwater, we want to see pathogens and other contaminants removed. And the biological mat is very important in that. If the biological mat becomes damaged by chemicals that you're adding to the septic, if it becomes overloaded with solids because of a poorly functioning septic tank, or you're adding a lot of extra solids, like for example from a garbage disposal, it can clog this treatment area and result in poor treatment. You might be still getting water through it, but it might not be treating it to an effective level, and it could impact groundwater. And remember, in the biological mat, we had a variety of microorganisms. It was a zoological film, but we had in the outer layer, because the water is draining through this biomat in the area around the leach field line. It's wet, but it's not filled up with water. Water is moving through it. So you also have the possibility of aerobic bacteria, because there's air that support aerobic bacteria on the outside, and then you have anaerobic bacteria. And there's other processes such as absorption and filtration. And this is where 99% of the treatment occurs of that effluent. Maybe 1% or less than 1% occurs in the soil. So it's very important to protect this. So, and what we're going to be talking about is mostly in this inspection is making sure that our septic system is functioning properly, and most of that involves protecting the biomat. And there is some reasons to inspect. We inspect the site before we even construct, and we take into consideration different usage factors. Anytime there's a property exchange, in addition to a house, you're adding another bedroom, if there's complaints, or what we're mostly talking about today is time-based planned inspections. So we're checking the septic tank periodically and the leach field periodically. It all begins with a site evaluation, and we're looking at the property. We're looking at what are our required setbacks from roads and stuff. Are there buildings and trees and rocks that we have to keep the drain field away from? The contour and elevation, we basically want the drain field to be almost level, a very slight slope. The locations of streams and underground water sources, those all figure into the design. And we will have basically kind of a geological evaluation of the soil, which might include something as simple as a perk test or a more comprehensive evaluation. Perk testing, we're going to talk about that. I mean, generally, we're talking for the ideal soil about 0.4 to 0.7 gallons per day per square foot. So if you imagine, you look at the soil underneath your feet and you have a 12-inch by 12-inch area, we're applying about a half a gallon over a full 24-hour period. That's the rate at which that water is infiltrating through the soil. So it gives plenty of time for treatment, but it's not so fast that we don't get adequate treatment. It's not so slow that it leads to ponding. So there's a range that is usable. And depending on that percolation test, it'll determine the size of our drain field. Now, there's some examples here. One of the links that I shared with you in the references is this. It's basically a inspection checklist, and part of it is gathering initial data about the sizing of the tank and the assumptions that we've made about how big is the tank, how big is the leach field, how many people, how many bedrooms, that kind of thing. So this gives you some example of the types of information we might want to look back on to figure out where things are located and what was the initial assumptions of the design. For example, if a septic system was designed for a 2-bedroom house and we go out and the septic system is not functioning well, and we see that 2 extra bedrooms have been added and there's a lot heavier use, well, that would obviously be something that we can make a connection to and realize, okay, we're now overloading our drain field. So we also have different parameters. The parameters are the flow that we expect to go into the septic system, the on-site wastewater system, and also the strength of the waste. And you see about the 5th box down that talks about, is there fats, oils, and grease? Is there biochemical oxygen demand or suspended solids that are higher than these normal domestic waste levels? And if so, we would have some kind of additional treatment probably for this system. And if these values were to change, if the system was designed for a normal amount of loading, and these values changed in the future, say somebody added a garbage disposal or added additional flow, it could help us to troubleshoot and find the root cause of why the system is not functioning. And so it also helps us to determine the inspection frequencies, estimate the pumping frequencies. We can better assist the homeowner to identify types of problems or ways they can prevent problems. And the main idea here is using these specifications and parameters that helps us to determine, are the original design loading estimates still valid? And I would like to bring Dr. Barrett in on this general idea of inspection and how establishing, Dr. Barrett, how does, in what ways have you seen, I guess, communities improve their overall groundwater quality or success at on-site treatment just by implementing regular inspections?
Well, first of all, that's a novel idea. I would say that you may have a community that's not doing some type of inspection or oversight, and then they actually change and they begin to. I'm gonna just say everything we've seen is typically when you have an area that is all on site or septic systems, and there is no inspection or frequency of inspection that's going on, and it's causing issues, it's causing the problems, and then as a result, you're having to go out and do some type of kind of neighborhood system-wide pumping, cleaning, or potentially trying to convert them to some type of centralized system. So I know you asked the question in one way, but you know, in my mind, if we were able to educate the homeowners that are in these communities that have the on-site systems and understanding how if they do not keep them up or maintain them, the consequences that we may have to deal with are not good. So it'd be great if we could get people to understand and make that habit change to start having a better frequency of inspection or oversight on their system. And Greg, like I said, I know that's not exactly how you had asked that question, but a lot of what we're seeing is simply trying to get people on that path of habit change.
Yeah, well, I guess I had it open-ended because I didn't want to pigeonhole you, but you mentioned something interesting, Dr. Barrett, that sometimes it results in a community needing to go to some kind of centralized treatment, which that seems like a very expensive and a radical change in a way, where people could have just simply took some steps to make their on-site systems work better.
Yeah, no doubt, and you're exactly correct. It works best from a financial standpoint if there's an adjacent community that could potentially connect with them and start collecting that wastewater from those systems. Because yes, if you have a small area, it's usually not very viable unless they get some type of grant funds to do the initial construction and build out. So yeah, it's a costly endeavor if it has to go that route. But you know, and I'm sure we've got some TA providers on here that you see that when you start visiting with these communities and trying to find solutions, you explore options and looking at that cost benefit analysis of the greatest kind of gap between the cost there is where we want to be. So I'm not saying it's always adopted, but it's usually reviewed as an option.
Great, thank you. That's a very comprehensive answer, Dr. Barrett. And when we talk about maintenance planning, usually we want to inspect our septic at least about once every year, but depending on what we find at a site, that could be increased or decreased. Imagine an oversized septic that just has one person living there, and every time we go out and inspect it, the sludge and the solids aren't accumulating very fast at all. We might say, well, we'll inspect this once every other year. On the other hand, we might have a system that we see is having some problems. It's overloaded with solids and there's too much liquid flow. And we might say, well, we need to inspect this more often to see what's going on here. So the results of the inspection will help you to establish a maintenance schedule or to adjust it. You might start out with once every year. We can also start out with an estimate of pumping frequencies. And I'm pretty sure Dr. Barrett shared this in his first presentation, but just as an example, if we had a 750-gallon tank and a household size of 4 people, a rough estimate is that we would need to pump it every 5 years. That doesn't mean we would inspect it every 5 years. We would want to inspect it at least once every year, but we could expect, and that would give us something to compare by. If we find out we're having to pump more frequently than that, that would give us some indication, okay, there's some kind of additional loading here. Also, if you add something like a garbage disposal, I've mentioned the garbage disposal 3 times now, I think, but that is just one example of something that would add a lot of additional solids that tends to get into the drain field area, and it clogs. It adds to the solids, but it also can clog the drain field. And they estimate that the pumping frequency will decrease by about 50%. So instead of 5 years, maybe you're looking at every 2.5 to 3 years if you have something like a garbage disposal. Those are just some rough estimates. When we do a site evaluation, we have a perk test, and that's more than just seeing if the soil is suitable. And there's a lot of different variations in this at the county level and community level, but I'm going to give you just kind of a general example. The actual size and depth would probably be different, but you can see on your bottom, the right of your screen, there's an example of a perk test hole that's been drilled, and you can see they're measuring it with a simple yardstick. And we're looking at how fast that water percolates into the soil. The level will drop, and we measure that in inches. And normally it would be a minimum of at least 3 holes dug around the perimeter and at least 1 in the middle. And we're perk testing all those. Generally, if they're pretty close, we would take the slowest one for our design. So we design for the slowest. If they're radically different, it might require a geological investigation to see what's going on with that soil. But generally, the holes are about 6 to 8 inches in diameter, and they fill it with a certain level of water, 6 to 8 inches normally. Like I say, at different counties, that could be different. They might require a different diameter of hole and different level, but basically you're just trying to see how fast does the water go into that soil. And you want a percolation rate that is slow enough for treatment, but fast enough so you don't have a waterlogged drain field. And for some examples, really sandy soil, the perk might be 1 to 8 inches. 1 would be probably be a little bit too fast. You probably don't want your effluent to go through the soil that fast. So it might actually be unsuitable at 1, but 8 inches, I'm sorry, 1 to 8 inches per hour. Sorry, I said that backwards. 8 inches per hour might be a little fast. For loams and silty soil, it may be 1 to 2 inches per hour. And for clays, we're getting pretty tight. This is getting on the other end of the scale where it might not perk fast enough. You might have to have a mound system. And so there's a range that's generally considered acceptable between about 5 and 60 minutes. That's the big wide limits of what's possible to still put a septic system in. Now, when you get where it takes 60 minutes per inch, that's quite a long time. And so what effect would that have on our design? Well, it would cause us to have a much longer leach field, a much larger leach field, because we need more area to get rid of the water. So on the top diagram here, we have a percolation rate for 1 inch, like 11 to 30 minutes is a range, and we're estimating that we might need about 200 square feet of drain field area per bedroom. Whereas if we had a perk rate that's 61 to 120 minutes, we would need much larger, like 600 square feet of leach field. So it radically changes the amount of square feet that you need. And you can see the loading at the top there, 1 gallon per square foot. That's pretty fast compared to, that's per day, by the way, 1 gallon per square foot per day. In the tighter soil, about 1/5 of a gallon, 0.2 gallon per square foot per day. So you can see you would need a lot more. You would need 5 times as much area for the 0.2 than for the 1.0 to get rid of that water. And then on the bottom, we can estimate the size of our tank by the number of bedrooms. This is just rough rules of thumb. 1 bedroom house, you can get away with 1,000 gallons. A 4 bedroom house, about 1,250, and a 5 bedroom house, about 1,500. I'm going to show you some rules of thumb for that as well. Some rules of thumb is that the wastewater flow from a house, and we're talking about combined, that just means we have gray water plus black water, toilet flushing and sinks and showers all going in. And so about 150 gallons per day per bedroom. So if you had a 2-bedroom house, we're estimating about 300 gallons per day. 3-bedroom house, about 450. So we're going to estimate with a 3-bedroom house. And another rule of thumb is that every gallon per day that's produced, we're going to need probably about 1 linear foot of drain field. This is not considering the width yet. This is just rules of thumb. And the tank size, about 2.5 times the daily flow. So these are rules of thumb that this is good to have in your mind. Then you can compare, okay, this system is either smaller or larger than this. So let's look at, if we use these rules of thumb, let's estimate this for a 3-bedroom house. We have 3 bedrooms, okay? So we estimated 150 gallons per day per bedroom. So 150 gallons per day times 3 bedrooms. What does that give us? I'm going to ask you to give me some answers in the chat. Are you all following along? Did I drone with my voice and put you all to sleep?
Nope, I'm getting all the same answer, 450 GPD.
Okay, I can't see them on my side.
Yeah.
Okay. Now, I'm not showing a calculation for this because rule of thumb 2, for every gallon per day, about 1 linear foot of drain field. So if we did a 1-to-1, we're estimating about 450 linear feet. And this is just an estimate. So usually the limit of length of these drain field lines is 100 foot. So that would be like 5 100-foot lines or 5 75-foot lines, something like that. And then our septic tank volume, if we take the gallons per day times 2.5, that'll give us an estimate of how large we want our septic tank to be. What do we get for that? Shout out an answer when you see it, Owen.
I got 900 gallons a minute. Then I got someone who said 1025. I got an 1125.
Okay, 1125 wins the prize today. So about 1125. So usually tanks don't come in that size. So we're looking at a minimum tank size of about 1250 gallons, right? So those are rules of thumb that can help us. And if we look at sizing of the drain field, we can look a little bit at the design. You can see this is from Missouri State Extension. And I shared this link with you. There's a lot of good design specifications and tips for septics in that link. But this gives you an idea. Here we have the distance between the trenches is about 3 times the trench width. So if your trench width was 3 feet, 36-inch wide trench, the distance between them would, from middle center to center, would be about 9 feet. And so that's how you can see them laid out. And the size, remember, we're looking at how many square feet do we need to get rid of that water. So if we had a 3-foot wide trench, every linear foot of feet would be 3 square feet, right? So that gives you a little bit of insight into how they're sized. And for inspecting drainage fields, we have a couple of different things we can talk about. One is looking for ponding. You can see an image of some ponding here where it was oversaturated, and we see actual, the soil might be spongy and muddy, or we might actually see ponding where the water is not able to absorb through because it's been oversaturated with more water use than it was designed for. Another option is to have monitoring wells around, and you can see this monitoring well on the left-hand side. That the left-hand well is a monitoring well, and you see it's monitoring the upper layer of groundwater, and where as opposed to a production pump, which is it's screened off, so it's usually not getting that surface water. It's going down deeper to a confined aquifer. But this upper layer of water is often where we have residential wells. So if you had a septic tank that was not performing well, and you're getting contaminated water entering into this upper layer of groundwater, it can cause some contamination problems. Also, another thing is you could have possibly a camera, like a snake type camera, where you could actually send through, if you had a distribution box, you could actually send that camera through and inspect the drain field pipe, make sure it's not clogged. And let's go into talking about inspecting septic tanks. Now remember, we talked about in both Dr. Barrett's basics and I think a little bit in the processes, we talked about this buildup of solids in the septic tank, and that's the purpose of the septic tank, to separate floatable from settleable solids and retain those in the tank and to decompose them slowly with anaerobic processes. When the total solids gets to be above about 30% to 1/3 of the tank volume, it means it's time to pump. And we want to periodically measure that sludge layer and scum layer, and also to see how close it is to the baffles, because that's the main thing in inspection that we can do. The most important is to make sure that solids aren't going out into the drain field. And so if we get up to 1/3, 30% to 1/3 of the tank, we want to pump. And you can see the inspection risers and pipes at the top there. And that would be where we would observe the inlet and outlet tees, and also be able to access the liquid contents to measure the solid levels. And here's a view of a excavated septic tank, the two lids. And you can see these don't have the nice risers above the lawn. I think it's ideal to have risers that are above, then you don't have to go and dig up lawn, and it gets pretty messy, but this was done pretty neatly here. So you can see that this septic has been the two inspection ports over the inlet and outlet has been excavated. And also in this image at the top, you can see an additional effluent chamber that contains a pump. So in some situations, you might have wastewater that needs to be pumped, for example, to a mound system or to a higher area. And in that case, you would be depending on that pump to operate with the floats in order to get that wastewater to flow out. And so one of the additional things you can do is to check those floats by lifting them manually to make sure the alarm float works and the on flow works. And so that's an additional thing that you'd want to inspect in your at least annual inspections. Here's another example. It shows the inspection port has been opened, and they had to do a lot of shovel work here because they didn't have that nice riser, but still a pretty clean job. And you can see the inlet tee there looking pretty good. And a couple things to notice: the water level is about at the bottom of the pipe, and the tee is not broken. Here's some other examples of things you might see in older systems. You notice that upper right picture, there was a baffle that was built in, kind of I think that might be metal, because the bottom picture, it shows a baffle that's metal and it's rusted away. So instead of a T, sometimes the inlet baffle has some kind of a built-in, kind of like a half pipe around it. And that's the purpose of the inlet baffle, is to prevent the scum from interfering with water coming in. And you can see on the left-hand side, you can see a different version of that same system, the inlet baffle, and then they're actually also pumping this tank. So that's some different views there. So if you see a situation like the bottom right, that would mean that you'd probably have to chip that out of the way, remove that broken material, and excavate a little bit around the pipe and add a T. And the T has to extend far enough down below the scum to make sure that scum doesn't interfere with water coming in. Here's some examples of some problems at the T. On the left, you see that the inlet T was plugged. It's probably because the scum level was too high. In the center, you see a broken T. And on the upper right, you see that the T is crooked. I think this is an outlet T, and that is most likely from the ground settling and the pipe going out toward the leach field is settled because the fill wasn't compacted well enough. And you can see another example on the bottom right of one of those baffles that's kind of built in. And this one looks like it's okay. Here's some different examples here on the left. No T at all. It's fallen off or broken off. Sometimes people will use a clamp, a metal clamp, and of course that will corrode away, or they don't secure it well. In the center there, we see that's an effluent T. It looks like it has a filter in it. It looks kind of messy, but I don't actually see any problems with it. You see a scum layer there. The filter would have to be pulled out and cleaned, of course. And also I see that the water level is about at the bottom of that pipe. It looks to be okay. On the far right, we have some problems there. Can you see what the problem is on the far right? Go ahead and put it in the chat what you see the problem is there. And let me know what the responses are, Owen, please.
Yep, sounds good.
So that far right picture, what are our problems there?
So I've got a couple responses so far. I got water is too low. There's cracks in the ring. It's not watertight. There's cracks in the concrete, cracked manhole.
Yes, you got it exactly right. So those cracks could let outside water come in and overload the system. So you'd be getting rainwater coming in, and the water level is down because they're pumping it. But that's a good observation though. And we're gonna bring up poll 2 now.
Launching right now.
And for the interest of time, when that gets up to about 80%, go ahead and tell us the results, Owen.
Yep, sounds good.
We appreciate you participating in the polls and in the chat. That really helps, because on this webinar platform, it's kind of like there's a wall between us. We can't really see each other, but the participation really helps, and I hope you're enjoying the information so far.
Okay, maybe closing the poll in about seconds. Okay, so for results, it was split primarily between two. The all of the above had 38%, and then 62% said it's to compare original intended design with current loading.
Excellent. And this was the question, why are records important when diagnosing problems in on-site wastewater systems? And we want to be able to see what was the intention and what has, if anything, has changed if there's problems. Here you can see a septic tank that has those nice risers that make it easier to access without having to dig down. You can see the effluent filter. Notice the water has to go through a barrier to get from tank the left side to the right side of the tank, and then up through that filter, and that helps to remove some of those excess solids that could get into the drain field. And here's an example of some of those that you might see in the effluent side. You can see those filter on the left is installed, and on the right, a little bit different kind of a model, but it's being pulled out to be checked. And when you pull a filter out, you can observe how dirty is it. I mean, if that one on the lower left looks pretty dirty, we're getting a little echo, Owen. I'm not sure if there's something you can do on your end. Thank you. But we might want to inspect that filter more often. You see on the right-hand side, we're pulling out that filter. It doesn't look too bad. And if you clean that filter with a high pressure hose, that's the best way to clean it. And you want to hold it right over the port so that the hazardous material goes right back into the septic tank. And here I was talking about the pumping tank. Here's an example of what you could see if you have a septic with a pumping tank. And on the top, that upper right picture, you see there's a union, that wide piece of PVC that you can unscrew. That makes it so you can unscrew that and pull the pump out if you need to. And also those wires are hooked to floats, and you can lift those floats one at a time. There should be an alarm float. When that activates, you should see something like a little light go off. And then the on and off float, you should be able to lift that to cause the pump to go on and off. Now, let's talk about measuring scum and sludge. There's a couple things we want to look at. We want to look at the overall thickness of the scum and sludge layer. And also we want to see how close the scum is from being able to enter or interfere with our T's. And we want that distance where that red arrow is on the right-hand side of your screen. We want that to be at least 3 inches or more. If it's less than 3 inches, regardless of how many solids are in the tank, we want to pump. And it might be a situation too where you say, well, there's not that much scum and our inlet or outlet T is actually not long enough. So that's a possibility as well. So how do we do it? We can get a piece of PVC and make a little L on the end, and we can measure down till we feel resistance. We sneak it through that inspection port, and then we also push through the scum and back up, and we make some little marks on our scum measurement stick, and then we can actually know how thick our scum layer is. We can also do the same to measure down to the bottom of our T, and then we'll know the distance between the bottom of the scum layer and the inlet of the T. So that distance right there, we want that to be 3 inches or more. And here's what it might look like if it's, by the way, that if that measurement is less than 3 inches, we want to pump. Our scum measurement stick, just a piece of PVC with an L on the end of it can work. And you notice if we did those measurements that we just described, we would have the top of the scum layer, the bottom of the scum layer, that would give us the thickness, and then the bottom of the inlet pipe. So that would give us the information that we need to know how much scum do we have and how close are we from scum entering into the T. We can also measure with a sludge judge, and this particular sludge judge on the right picture, you can see the bottom has the dark sludge, the top has the lighter colored scum. So it kind of made a profile. A sludge judge is basically a clear plastic tube with a check valve. You push it down through the sludge, and as you pull it up, the check valve closes. And so here's an example of doing that. Then we have a kind of a profile, sludge at the bottom and the scum at the top, and then we can actually measure the thickness of that sludge in inches. We don't have to do a volume measurement. We can just do the inches. We have the tank depth compared to the depth of the scum and the sludge. And in this case, we'd have a measurement of sludge, about 10.5 inches of sludge with that dark sludge sample ends. Oops, I was a little too fast there. There's another method that you can use by just using a stick, 2x2 long board with a flatter, wider board attached firmly to the end, and you can push it through with the top image there. You're pushing it through, and you feel resistance when you hit the top of that scum layer, and when you go through and pull back up, you'll feel resistance. And you can also make pencil marks or marker marks on the stick. And you can do the same with the sludge layer has on the bottom. You can feel resistance when you get to the top of that sludge and you push it all the way to the bottom of the tank, and you can make pencil marks and measure those two distances. And so what we're looking at is to see what percentage of the tank is taken up by solids. And so we're going to use those measurements. For example, this tank is 48 inches total depth, and we have scum is 4 inches and the sludge is 8 inches thick. So we can do a little calculation and just say, okay, the total solids is 12 inches thick. And we can take that 12 inches divided by the total depth of this tank, which is 48 inches in this case. A lot of tanks will be deeper than that, 60 inches perhaps. But if we take 12 divided by 48 and convert that into a percent, we get, okay, we have 25% of the tank is solids and 75% is liquid. So we wouldn't have to pump because we're less than 30%. Another thing to look out for is the liquid level. I mentioned this before, but the liquid level should be even with the outlet, because that means water, if water comes in, it's able to flow out. So we're looking at that outlet drain, and it would be problematic if you had settling and that outlet T is slanted. That would kind of mess up your, the performance. And it could also pinch off the outlet pipe. Now, what would it mean if the water is higher than the bottom of the outlet drain? Well, there's something restricting water going out into the drain field. It means that the drain field's plugged or there's some kind of clogging in that line. So it's that much higher than the bottom of that outlet pipe. If it was lower, what does that mean? Water is leaving by some other means and going out the outlet drain. That means we have a potential tank leak. So untreated water is coming out of the tank and possibly making its way down to groundwater. There's another method we can use to inspect tanks that's very useful. We can have a little sewer scope, they call it. And you can see this gentleman on the right, on the left, has like a camera on like a snake, and he's able to go down and look at the structure of the tank. What we see on the upper right, we're looking at the structure of a cement or concrete septic tank, and it actually looks pretty good. The integrity looks good. However, down on the bottom, we can see that there's some deterioration in that center wall. So if scum were to rise a little higher in that tank, it could actually flow over into the effluent side, and we don't want that. So those are the types of things that we could look at with a sewer scope. Other things that you can see sometimes, if you saw roots growing inside of a tank, that would be a bad sign. It would probably let you know that there's also roots that are affecting the drain field. And those same sewer scopes could be sent down into a drain field pipe, and you could look inside of those as well. I talked about this settled piping. You can see the outlet pipe is crooked. Well, that's because, and the inlet pipe is crooked because some settling has occurred. There was the backfill was too loose, it wasn't compacted enough, and that could actually collapse the line and cause it to back up into the house, cause the septic tank to overflow, and also it just disrupts that nice even flow into the drain field line. Now we're going to go to pole 3, and I have a question for you. I'm going to bring up the image. And the poll asks, does this septic tank need to be pumped?
I'm going to give everyone a few minutes, well, a few seconds just to look at the image, make a decision, and I will launch the poll in about 10 seconds.
And Dr. Barrett, I'm going to bring you in right after we get the answers here. And I'm going to give you an open. I'm not going to ask a specific question unless you'd like me to. I give you kind of your reflection on some of the things in this presentation you might have seen that you'd like to highlight or add on to. Maybe something I missed that needs to be said.
Okay.
I'm gonna close the poll in about 5 seconds. Okay, so for results, we had 64% of people saying yes, 20% said no, 10% said depends, 6% said I'm not sure. And then in the chat, we had a couple of responses, yes, 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 no. And then someone said that we need to know tank total depth divided by volume, or depth and volume.
Okay. Very good. And when we add, when we add the 12 inches plus the 20 inches, that gives us 32. 32 divided by the overall depth of 60. I guess, you know what? I see that there was probably something kind of confusing about this image. That 60 inches almost made it look like that center area was 60 inches. The 60 inches is the overall depth. I should have made that clear. But what we're doing is we're total depth of 60. 32 divided by 60 is over 50%, which is more than 30% or 1/3. And so we would need to pump it. And Dr. Barrett, the floor is yours.
Am I here?
You're here.
Okay, hey, good deal. Yeah. If I was going to say anything, and again, I'm not, 100% sure of our audience. It seemed like from that initial poll, we have a lot of people who regulate the septic systems across the states, whatever states those may be. Just one of my thoughts from the amount of I'm gonna say care that needs to be taken to septic. I think it's very important, for one, as it protects our groundwater, because everything that we're seeing and finding is that we're not necessarily, at least in my region, we don't seem to be having a reduction in the number of people that are on septic, or a reduction in the number of people that are on wells. So this is not a shrinking base. This is it's either plateaued or continues to grow around here. So to me, I think it's just that much more important that we impress upon any of these homeowners that y'all go out and visit with when you may be doing a site assessment or doing a percolation test, about the importance of maintaining their on-site wastewater system, just because of, if it's not maintained, the negative impacts it can have to the groundwater right there where they are, or bleeding over into adjacent properties or adjacent homeowners. So just driving home that point of, even though these are individual, they're still very important and can provide a good, safe method for treatment, but we have to maintain them. It is your responsibility as a homeowner, as an owner of the system, to maintain. And I would say point them to, EFC resources, because they're here, they're available, and that's what they're for. So that's what I've got, Greg.
Excellent. Thank you so much. I want to end with some suggestions that we might be able to track the performance of our inspection program over time. Some basic metrics we could use is how many problems or complaints do we have per year, and we would hope that those would go down over time. Groundwater monitoring results. If you had, Dr. Barrett mentioned checking private and public wells that are already in existence and who are already doing water quality tests, in addition to maybe monitoring well results over time. We would hope those would get better. Some other metrics might be how many inspections are being conducted per year, how many corrective actions are being taken, and the planned maintenance ratio is a good one too, because sometimes you might have emergency type inspections where something has gone wrong and you need to get out there and see what's the problem, versus just a planned inspection where everything is okay. You're just doing normal checking of the levels. And there are situations still where there's waterborne illnesses, where a neighbor has a malfunctioning septic system that impacts the groundwater quality. And a consistent inspection program can actually help to educate the public and keep their systems functioning well. So that's a little bit of a culture change, and it involves public education and just a commitment to that periodic inspection of on-site wastewater systems. I want to thank you for all of your great input today and all of your participation. And I want to invite you to share something that you learned about today, that you enjoyed learning about today in the chat. And in the meantime, I want you to know that you can find resources at efcnetwork.org. And in specific, there's funding tables where you can look at various funding sources for your state and territory. And when you open up the funding guide, it will look like a map. You just click on your state and it will give you federal and state sources of funding. And here's my contact, G. Pearson at mtu.edu, and the Environmental Finance Center Network website. And I'm coming from the Great Lakes Environmental Infrastructure Center, which is Region 5. So if you're in one of the 6 states in Region 5, up there in the Northeast, Midwest area, you're welcome to visit our site as well. Dr. Barrett, any final words as people are sharing what they've learned today?
I just say thank y'all for participating, and thank y'all for participating in this series. I think it's valuable. I know sometimes if there's been any of y'all that have been on the webinars that Greg and I have done over the last couple of years, I know we're digging into the same information and hopefully trying to hit it at different angle points to make sure it's valuable to y'all. But continue to log in, and if there's any interest for other topics or a different angle to look at some of this stuff, please let us know. I feel like that's what Greg and I desire to do with our work with the Environmental Finance Center Network.
Any pressing questions, Owen, that we need to address?
Yeah, there's a couple that might be good to get through right now. One very quick one, someone was just wanting clarification. How often should a septic tank be pumped?
Well, there's a rule of thumb based on the number of bedrooms and the size of the tank, where you can get an estimate in years. That would be adjusted with data. So for example, if you inspect the septic each year, you can see how fast the scum and the sludge level is increasing. Let's say the sludge level increases 3 inches per year and the scum layer increases 1 inch per year. That would give you a good estimate of when the total solids is going to be at 1/3 of the tank. Anything to add, Dr. Barrett?
No, sir.
Okay. One of the other questions that was asked is, I don't think my management will go for me taking scum/sludge measuring sticks on inspections with me. Are there visual signs I can look for on the surface of the wastewater from the inspection port? Apologies.
If you had some kind of a waterproof camera, it's possible. I think, I mean, you might be able to use something like sonar. I've never heard of anybody not being able to accurately measure those levels without having at least a sludge judge. And it is a hazardous waste that you'll have on that tool. And it would have to be, I mean, the way to keep it safe is to wash it off over top the open inspection port and wash all of that material in, all the debris back into the tank, and then have some disinfectant with you. And of course, you'd wear gloves and you'd disinfect that tool before you put it away.
Okay, great. There are two other questions just before we get to those last two. If people need to get going, that's totally fine. There will be a recording added into the email that's sent afterwards. So just wanted to leave with that. The last two questions I have, do you know of any private funding entities as well for homeowners?
Occasionally there is. It depends on the state. Uh, if if you go to that funding guide, you might see something. But also send me an email because I do have some information on it. It depends where you're at and the program. If you send me an email to gpearson@mtu.edu and you're looking for some specific funding, I'll do some research and compare it with our colleagues throughout the EFCN network, which is nationwide, and see what we can come up with. Okay.
Fantastic. The final question is, we are working in a community that desperately needs a community wastewater collection and treatment system. Soils are poor, lots are too small for conforming septic systems. How can we demonstrate the systems are having negative impact on surrounding groundwater and surface water, inadequately treating waste with no wastewater treatment plant to connect to?
Yeah, that's a good question. You'd want to get maybe a letter from the local county jurisdiction supporting that. You can also get an engineering evaluation. There is a way through an EPA technical assistance request now to get engineering support. And so that would be part probably of a preliminary engineering investigation. And so there is some financial support for the initial engineering evaluation. And a letter from the county and any kind of water quality data you might have from groundwater monitoring wells and so forth would all be useful. And once again, I will help do some research. If you'd like to send an email to gpearson@mtu.edu, I would share it with Dr. Barrett and our other colleagues, especially in the area, depending on the area where you're at. So that's what I would say.
Okay, fantastic. Huge thank you to Jason and Greg for sharing their expertise with us today. Following this webinar, you will receive a follow-up email with the slides from today and the link to the recording. We also ask that you complete the webinar evaluation following the webinar, so you can let us know your thoughts on today's session, as this helps us plan for future webinars on topics important to you. Thank you again, and we hope to see you at future EFCN events. Anything you would like to finish up with?
I want to thank everyone. Dr. Barrett, thank you so much for joining us today.
Hey, very welcome. Thank you all for inviting me.
Okay, thank you everyone.